Hi everyone. So, who here ever asked themselves, can LLMs generate cute pixel art? Yeah. Okay. 1, 2, 3. All right. Cool. So that was more of a fun idea that I had. I want to do some other like fun simulation games with that has to do with generating a lot of pixel art assets, and I could do things like use DALL-E to generate it. I could do things like using Nano Banana to generate it, but I don't have like full control over the pixels because they're actually giving out like full-fledged PNGs. So I was thinking maybe I can constrain the models so that I could have full control over each token that I generate, and each token would represent a color, and I would see if I can actually generate some pixel art with it. So this is what I did. So I went a step down into the token generation layer. I'm going to load in a OSS 20B model on Modal. Modal I'm using for just to set up my models here. And all right, so we have the models loaded, I think, or they are loading right now. And what we'll see is just some normal generation. So I'm going to talk about what the constrained decoding is. So if I were to just run this prompt, I would see all my tokens stream out. And as you all know, LLMs spit out tokens by tokens, but they actually don't spit out specific tokens. They're spitting out probabilities or logits. So like unnormalized numbers from -infinity to infinity. And then we can turn that into probability distribution, which you'll see down here. And for each token, I could see how likely they were to actually get picked. So this is really cool. And just to demonstrate what constrained decoding really is, so if I look here, there's an EM dash. And if you're like me and you make generic LinkedIn posts, you don't want EM dashes or people are going to think you're a robot. So what you can do is ignore those dang dashes and actually remove them from the tokenizer's vocabulary by turning those tokens predictions into negative infinity values so that they're no longer part of the probability distribution. Now we don't have the EM dashes coming out anymore. So this is really cool. And this is the idea with constrained decoding, but you can do it like at another step and actually remove all the tokens from the vocabulary and only focus on colors. So this is what I did here. So if you look, all of these colors, or pastel, cute little colors, are associated to a specific token. So RGBY, OPWK, and dot for transparent, which happens to be better than T. And when I have this and I decide to generate a heart, now I can see that token by token, I actually get colors that are coming out. This is cool. This is really cool, but it doesn't work. It doesn't work at a bigger scale. So if I go bigger and I decide to do this, you'll see that I start getting a bit of anything. It's too much. Thank you. Thank you. Reason being is that it's a bit more complicated to do the constrained decoding for tokens. It doesn't work in the same way that you would think like a regex works, where you're doing character by character and you're just limiting what you're actually outputting by character, because tokens are varying in sizes. As you can see here, the probabilities are really different. Sometimes we'll have like a couple of dots and a couple of new lines. So you really have to allow like a very big set of tokens. You can't really constrain it to those specific tokens. So bit of a failure, but this turned into a different project, which ended up sort of like benchmarking large language models for pixel generation. So I started adding other models, increasingly going up in weights. I went to Furrow Mini and tried to see like what it did. So if I were to put Furrow Mini in here, I realized that Furrow Mini does a lot of circles, and for some reason it just knows to make pixel grids but in circles. So I can't stream it. This is not a circle, but this is what Furrow Mini does. And I was really sad because there isn't really a good model that actually gave me good pixel art generation until this week. Gemini 3, bum, bum, bum. So, I mean, we can keep going with the hard, but I just tried a duck with my friend and actually did the duck pretty well. So there's two levels of reasoning with Gemini 3. There's low and there's high. I'm gonna use low. And look at this! Look at this! It's really cool. And I could do a bunch of these, and it's around like 6 seconds to run. And now I have pixel perfect Porian. Sorry, I'm typing with one hand. Pixel perfect images that I can use for the game that I'm trying to make. So we'll do a health potion, but what's cool is that like when you have such a granular level of control, that you can actually start changing some of the. Okay, enough clapping. You can actually start changing like some of the colors. So maybe you want to like turn this into a poison potion. I can do that type of stuff. So this is what like I can't get from normal diffusion models, actual like control over the tokens that I have. So yeah, that's pretty much it. I don't know if we want to like jump in the code or ask some questions. Yes. Oh, for the heart. Let's check it out. Heart, and we can increase the pixel size as well. See how long it takes. Yeah, so it usually does pretty good. And I was actually reading about Gemini 3 today, and it turns out that it's really good with like SVGs, but also really good with voxels. So I don't know what they did, but it's a huge step up from other models. And even testing out with GPT 5.1, turns out that it's probably going to give me something like pretty good. I was happy with it before Gemini 3 came out, but that's like now it's my new toy. It's Gemini 3. It's a completely different like paradigm. It gets it right all the time. So.
Is that an issue with the word size?
The what?
It's not an issue with the word size because I guess when it's following a sea of points, you don't know where he is.
Yeah.
That's the tokens too much.
It's a very good point. And so this is the same concept as like when you're using OpenAI's API and you're doing like structured outputs. It's the same concept. You're creating these constraints that allow them to output like JSON specifically like all the time. But they also always inject the schema of the JSON with it, so that it guides all of those tokens that are most likely to come up to the top. So that's what I did. I still have a prompt. I'm not just prompting the specific item that I want. There's also a prompt that's paired with it that explains what tokens represent which color, what should go in, and what like a typical like drawing would look like. So like a few shot approach to actually generating an image. You could see it here, like the main prompt, and then also at each step what it looks like when it's unconstrained, what the tokens normally come out as, which is usually just a series of dots. But you'll also see that sometimes it's a couple of tokens paired together. And I actually had a lot of issues with the colors from the letter O and the letter K, because each time that I would start a generation, it would say okay. So I would always have like those two colors at the start because it was just agreeing all the time because it was the only thing that it knew how to say. Yeah. So and some other words that it can make up as well. That's pretty cool. Yeah, that's pretty much it. I don't know if we have anything else to add. Yeah.
Have you tried removing something else in your first here? In your first example, have you tried removing something else other than M dash? Because I've seen the experiment where they remove the ability of the model to use the token that represents the letter E and started asking it about the elephant, and it avoided saying the elephant at any cost because
yeah.
So did you try something like that?
You got me. So yes, I'm actually happy you asked that question because so I first started constraining the EM dash, but then it started using all of the other characters that they could represent a EM dash, up to dashes, up to like the minus, up to like every character that might look like it. It was using it. So I ended up removing all of those characters. So it's not just the EM dash, but I actually can't like bullet point anything in README. So sort of a little trick here, but I wanted to explain what constrained decoding was. So I think that was a good example. But yeah, it definitely has its flaws, and it's not like perfect, but there's a whole science to it when it comes to outputting structured JSON, creating finite state machines with a set of grammars. Like it's a very specific science. I don't recommend anybody getting into it because people have it handled, but it's fun to get into, especially like at that layer of token generation.
Out of curiosity, have you tried to search for something that is not really drawable, like emptiness, loneliness, something that's not really a picture?
The loneliness.
Loneliness. Gonna show a picture of us.
How many pixels do you want? The grid size. Like, I don't think. Yeah, we're gonna kill Google. Let's do 16 by 16 and see what happens. And it's cool as well. Loneliness is a gray mountain. I mean, loneliness, but in deep mode. That's what we needed. We need to be deep about loneliness, else it wouldn't be deep, right? But this actually takes like a minute more. So we have, I don't know if we still have time, but yeah. Do we have another question?